Lesson: Model drift and degradation over time. Model drift and degradation over time present significant challenges in the field of AI model development, particularly for professionals engaged in blockchain and AI risk management. The phenomenon of model drift refers to the gradual decline in model performance due to changes in the underlying data distribution, external environment, or the system's inherent dynamics. This drift often leads to model degradation, where the accuracy and efficiency of predictive analytics diminish over time. Addressing these challenges requires a thorough understanding of actionable insights, practical tools, and frameworks that can be directly implemented to enhance the robustness and reliability of AI systems. One of the primary causes of model drift is the non-stationarity of data. In real-world applications, data distributions are seldom static. They evolve due to various factors such as market trends, consumer preferences, or technological advancements. For instance, a model trained on historical sales data may become less effective as new consumer behaviors emerge post-pandemic. This change necessitates continuous monitoring and adaptation of the model to maintain its predictive power. Practical tools such as data drift detection algorithms like Kolmogorov-Smirnov tests are instrumental in identifying when significant changes in data distribution occur. Once model drift is detected, the next step involves recalibrating the model. Techniques such as online learning and transfer learning are particularly useful in this context. Online learning algorithms, for example, incrementally update the model as new data becomes available, allowing it to adapt to gradual changes without the need for complete retraining. Transfer learning, on the other hand, leverages knowledge from related domains to enhance the model's adaptability to new tasks or data distributions. This approach can be particularly beneficial in situations where labeled data is scarce or expensive to obtain. Model degradation can also be addressed through the implementation of robust validation frameworks. Cross-validation techniques, such as K-fold cross-validation, provide a comprehensive assessment of model performance by partitioning the data into multiple subsets and training the model on different combinations of these subsets. This method helps to ensure that the model is not overly fitted to a particular dataset, thereby enhancing its generalization capabilities. In addition to validation, regular model audits are crucial for maintaining model integrity over time. These audits involve evaluating the model's performance metrics, such as accuracy, precision, recall, and F1 score, to identify any potential decline in predictive power. Automated monitoring systems can be employed to trigger alerts when performance metrics fall below predefined thresholds, prompting timely intervention. Furthermore, integrating explainability tools, such as SHAP or LIME, can aid in diagnosing the root causes of performance degradation by providing insights into the model's decision-making process. Another critical aspect of managing model drift and degradation is the adoption of a continuous deployment strategy. Continuous deployment facilitates the rapid integration and testing of model updates, ensuring that the system remains responsive to changes in the environment. CI/CD pipelines are widely used in this regard, automating the processes of building, testing, and deploying models. This approach not only streamlines the deployment process, but also reduces the risk of introducing errors during model updates. Case studies from industries such as finance and healthcare demonstrate the effectiveness of these strategies. In the finance sector, for example, algorithmic trading models must adapt to volatile market conditions and regulatory changes. Firms employ continuous monitoring systems to detect data drift and implement rapid model updates to maintain trading performance. Similarly, in healthcare, predictive models for patient diagnosis or treatment recommendations must remain accurate as new medical research and patient demographics evolve. By leveraging online learning and periodic model retraining, healthcare providers can ensure that their AI systems deliver reliable and up-to-date predictions. Despite the availability of these tools and frameworks, challenges remain in effectively managing model drift and degradation. One such challenge is the interpretability of complex models, such as deep neural networks, which often operate as black boxes. Enhancing model transparency through the use of explainer models or interpretable architectures is essential for building trust and facilitating model audits. Additionally, the integration of domain expertise is crucial for contextualizing model outputs and ensuring that adaptations align with business objectives. A proactive approach to managing model drift and degradation also involves fostering a culture of continuous learning and experimentation within organizations. Encouraging data scientists and engineers to explore new methodologies, stay abreast of industry advancements, and collaborate across disciplines can drive innovation and enable more effective risk management. Organizations should invest in training programs and workshops that equip professionals with the skills and knowledge necessary to navigate the complexities of AI model development. In conclusion, model drift and degradation are inherent risks in AI model development that demand vigilant management to ensure sustained performance and reliability. By employing practical tools and frameworks such as data drift detection algorithms, online learning, transfer learning, and continuous deployment strategies, professionals can effectively mitigate these risks. Case studies from various industries illustrate the real-world applicability of these approaches, underscoring the importance of continuous monitoring, validation, and adaptation. As the field of AI continues to evolve, a commitment to ongoing learning and collaboration will be crucial for professionals seeking to excel in blockchain and AI risk management.